S. Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we have done in mathematics the partial differential equation.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
Welcome to SN Academy and my name is Kanhaiya Jha. In this video, we'll focus more on the wave equation and its application and its particular solution. So we'll focus today with the element solution. And in element solution, what we can see is we have to take the wave equation. Wave equation as such, when the function is forming a wave in terms of amplitude, time period, frequency, and then we make the equation of that. The equation is made, as I have mentioned in the slide, that equation, the use of the variables is because the solution of the wave equation behaves in specific fashion, that is, the spectral movement is related to the temporal variation through the constant c. So we can see here that du by dx, we are taking the two variables u and v, and du by dx is equal to du into dv, dv into dx, plus du into dz and dz into dx. So here we can see that how we are breaking the particular variables in terms of ux, uy and uz, ux, uv and uz. We are taking the three variables. So if we focus here, then what we will get is du by dt in this, and then we have to calculate the wave equation. So let us understand that how we will make the equation in terms of the wave equation. Suppose that we have any particular, so y is equal to a cos omega t plus phi. I rewrite here that a cos omega t plus phi, and what we can do is this is the basically a displacement equation. From this particular displacement equation, we can calculate the velocity and we can calculate the acceleration also. So here we can see in this particular slide that the variables are given to us. The variables are given to us, du by dt is given to us. So we'll calculate du by dv into dv by dt, then du by dz and dz by dt. So we are calculating this particular variables, and we are calculating for all the particular variables. So once we calculate it, we'll get the velocity, then we'll calculate the acceleration. So we can see here that when we are calculating double derivative here, that is when we are calculating double derivative ux0 du by dt xt, that when we are calculating, then we are making for all the variables u, v and t. So here what we need to understand here, that in the particular given wave equation, first of all what we have to do is we have to calculate the particular value of the displacement in terms of the variables u, v and w. Then we have to differentiate the values of the u, v and w. So here we can see that du by dt is equal to du by dv into dv by dt. So here du by dt is equal to du by dv and dv by dt. So plus it will be du dj over dg by dt. This is the equation that we can use. Okay, so what we have to do is that du by dv is the constant function, the wave function that we are using, du by dz. So this in collection of each, it will gives us du by dv minus of du by dg. So what we have to do is we have to convert this derivative into x and into v. So what we will do is that we will calculate the duv, d square v by dv dj. So it will be dj by du by dv is equal to 0. This is the equation that we want when we have du by dv is equal to f dv. So if Vg, that f v dv is equal to xi z, so this is the equation that we get, and this is what D elements equation that we need. So what we have to do is that first we have to form a wave equation, that we have to understand what is a wave equation. The wave equation is that when the wave is varying, it has a periodic variation or a periodic oscillation, and then we are calculating this. So first we can calculate the velocity into different components, and then we can calculate the acceleration also into different components, and then we can make the particular solution. So what we have to do is we have to first calculate the differentiation in terms of u, v and z, and after that we have to calculate separately for u, v and z, like we have discussed du by dt. The previous slide, if you see, then we have clearly mentioned that v is equal to x plus ct and z is equal to x minus ct. So we have taken two variables here, v is equal to x plus ct and then z is equal to x minus ct, okay, and then we have to calculate u, that is x t, that will be equal to u vg. So first of all we are taking the function v in terms of x, then we are taking the terms of v in terms of z, and then we are calculating u in terms of xt, which is u v z. So what we are calculating here du by dg. We are calculating du by dg, and then we are calculating dv by dg. So if we can see in the next slide that du by dt and then d2 u by dv dg. So this is dv dg that we are calculating. So we are calculating the change in the particular wave equation. So when there is a change occurring in the wave equation, we are calculating this here. Here if you see here that if uxt is 0 at a particular time, uxt is equal to 0, then fx is equal to du by dt and xt is equal to 0 is equal to gx. And for the particular solution, what we do is that ux0 is this particular equation. So we basically what we are doing is vxt is equal to 0, okay, and then fx here is equal to du by dt, okay. So this is xt equal to 0. So this is equal to gx, right. So basically what we have is u x0, this is what we have to calculate, then we have to calculate du by dt and then du by dt xt, and then you will calculate du by dt at x is equal to 0 by dt at x is equal to 0. So when we say at x is equal to 0, it means that we are evaluating it from the initial point. We are taking the variables from the initial point and then we are making the particular calculation. Whenever we are saying then at that x is equal to 0. So we say that this is x is equal to 0, so uxt is equal to 1 by t fx plus ct plus fx minus ct plus 1 by 2c, the integration of x minus ct to x plus ct gs ds. So this is the solution that we have to generally do, which is D-Helmholtz solution. So we have taken here, starting from the first slide, we can see that we have taken the variable b, then x plus ct, then z x minus ct, then u x tt. Then we have differentiated this with in terms of v, in terms of x, and in terms of u. After that, what we have done is that we have calculated double derivative, and then we have integrated the value. Integrating the value, and we are taking the value, starting the value of x to be from 0. So from there we are calculating the particular solution of the given equation. So if the initial conditions are given that x t is equal to 0 is equal to fx, then du by dt x t is equal to 0 is equal to gx. So it will form that ux0. So this is du by dt xt will be calculated. So in this wave equation, any kind of wave equation that we are forming, what we have to analyze is that our equation is able to calculate the variation of the particular wave or not. So, the particular wave may vary from one particular point to the another point, in terms of time period, in terms of frequency, in terms of angular frequency and all. So, what the equation is saying that when we are calculating this particular equation in terms of different variables, then the equation should be able to calculate the changes which are all the changes which are occurring in the wave in terms of all the particular variables. As we can see that we have taken one value x plus Ct and then another value x minus Ct. After differentiating it, we are again calculating the value when x is equal to 0 from the particular beginning point. So, when x is equal to 0, and from there what we have to do is we are calculating the integrated factor and then the D-element solution is completed. So, the solution is basically meant so that the different variables of the waves can be calculated. Either the waves is propagating whatever the type of the propagation is, and the nature of the changes can be calculated very easily. As we can see, x is equal to 0 from the initial point, we are able to make the calculation and all. So, what we have learned is the wave equation in a type of different variables. Now, what we will do is we will implement this particular equation in a given example. We will learn that how we generally solve this particular equation with the particular examples. So, now we will take a small break, and after the break we will take the examples of this.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back, students. So, before the break, what we have learned about the wave solution. So, now we will take some examples to learn that how they are generally solved. So, here we can see that we have to determine the solution of the wave equation in D-elements form. So, it is given that dux by dt square is equal to du by dx square, okay, and x is from 0 to pi when t is greater than 0. So, we can say that when ux is equal to 0 is equal to fx, here we can see it is sin 2x, and du by dx x is equal to 0, gx is equal to sin x. So, here in this graph we can see that the particular the variation is given to us of the particular wave. So, here we can see that starting from 0, then going here, then coming here, and then going here. So, this is the mean point. Here we can see that 0 is the mean point. From 0, the variation is generally occurring in the wave. Here we can see that if we in the slide that from the 0th point, the variation of the signal is occurring. And what is given here is that d2u over dt square is equal to dtu over dx square, and we have keep the value of x to be like this, between this and t we have taken as greater than 0. So, what we have taken is here this particular value. So, from here what we conclude here that in ux0 is equal to fx, that is sin 2x, and u du by dt x0 is gx, which is of sin x. This is what we have to analyze. Now, we will solve the equation from c is equal to 1. That one, when we are saying c is equal to 1, uxt is equal to half x plus ct plus fx minus ct. So, we will calculate first u x t, okay, is equal to 1 by 2 fx x plus ct, and then f x minus ct plus 1 by 2 c integral of x minus ct to x plus ct gs ds. So this is the equation generally formed. So we have all the values now, and when we have all the values, then we can put in this particular form. So fx plus ct is plus fx plus t is equal to sine 2x plus 2t. So it will give us this equation, fx minus t is equal to sine 2x minus 2t. So first of all, from the wave equation, what we have to calculate, that what will be the value of gs and what will be the value of x plus ct and x minus ct. Then the first thing that we have to do is we have to make an equation u xt is equal to 1 by t f x plus ct plus f x minus ct plus 1 by 2 c x minus ct x plus ct g s ds. So this is the particular equation. First we have to form this particular equation, and then we have to put the variables in this particular equation to solve. So we say that fx plus ct is equal to fx plus t is equal to sine 2x plus 2t, and fx minus t is equal to sine 2x minus 2t. So we can here getting the integral factor that when we integrate the value of gs from x minus ct to x plus ct gs ds, so we can put the value of sine s ds x minus c to x plus c. So when we integrate sine, we will get minus cos s, and the lower limit here is x minus t and the upper limit here is x plus t. So cos x minus t minus cos x plus t. So we will get this particular equation, and then we will solve this particular equation in terms of u x t, which is half sine 2x plus 2t plus sine 2x minus 2t plus half cos x minus t minus cos x plus t. So this is the calculation that we can generally do here. I repeat that first of all, what we have to do in the given wave, we have to calculate c plus t and c minus t, the x plus ct and x minus ct. Then we have to calculate the value of gs. So once we have calculated the value of gs, then u x t is equal to half f x plus ct plus half plus f x minus ct plus 1 by 2 c integral of x minus ct to x plus ct gs ds. F x plus ct is equal to f x plus t is equal to sine 2x plus 2t. So f x minus t is equal to sine 2x minus 2t. So when we integrate it, putting this particular value, we will get this equation. So we will get this equation u x t after integrating this. So this is the simple solution, and whatever the nature of the wave, when the waves are given, to whatever the nature of the wave, we can make the solution from this particular equation. What we can do is, first that we can calculate the value of u x t. After that, we can calculate the value of gs. Then forming the first equation, which is the Helmholtz solution, the first equation u x t, u x of t, then when you put the values in this equation, we will get a simple solution of this. This appears to be the wave equation which is moving on the right. We can say that n is equal to 0, n equal to 0, 1, then 0, 3, then it's varying in this, and here you can see the variation. So the wave is varying from, this is the amplitude, this is coming down, here is the mean point, and then it is coming up and coming here. So what is the analysis, what is the physical significance of calculating this particular solution is that we can analyze the propagation of the wave. The propagation of the wave generally tells us that how it is moving, in which particular direction it is moving, and if there are changes occurring in this, then how the changes are occurring in this particular wave, wave equations and all that. So we will calculate from this particular function. So here what will happen is that we will calculate with this solution. So we will study now what is called as a wave propagation. So what we have done till yet was a wave equation, that what exactly the wave equation is and how we will calculate with the Helmholtz solution the particular equation, how we calculate with the particular different variables. After taking the variables, we will make this equation. Now we will calculate something which is called as the wave propagation. Wave propagation, we should understand few things here. The first thing is that this is the wave. Any particular wave, we can take it. You can take sine wave, you can take square wave, triangular wave, whatever the nature of wave that is given, we can calculate it. So the propagation will be in terms of the amplitude. The propagation will be in terms of the frequency. So in terms of the time period, angular frequency and the initial phase. The initial phase denoted by phi naught will generally matter because all the changes will be calculated from the initial phase. Whatever the changes occurring in this particular wave will be calculating from the initial phase. Then the changes in the amplitude. So suppose that this is the wave and the changes are there. So you can denote the changes here like this. So this will be the change in the particular wave. So now the equation that we will learn will enable us to learn that how to calculate the wave equation, and from the given wave equation how to calculate the changes in the particular wave equation, that how we calculate the different changes which are occurring in the particular wave equation. Here you can see in the wave equation that du by dt x0 is equal to gx is equal to 0. So we have taken that particular solution when c is equal to 1, ux0 and fx is equal to, we have taken a particular value 9 minus x square. So we have taken the particular value 9 minus x square. So uxt is equal to 1 by 2 fx plus t over fx minus t. So this is the variation that we will generally calculate here. Now again, when t, the time is greater than 0, we have calculated some calculations when the time was equal to 0. Now the time is greater than 0, then what will happen is that from the mean point the wave will come in the upward direction, whatever the mean point that we have chosen or whatever the mean point where the wave was oscillating. So from that particular mean point the wave now will propagate in the upward direction. As you can see in the slide that it is the particular wave. So either it can propagate at this side or either it can propagate at this side. But when t will become more than 0, then this will increase. As we can see that the portion here above the particular mean point, the portion above the mean point will increase, okay, in this when the time is greater than 0. If we are taking time more than 0, then it will again increase. Here also we can see that there are the characteristics line where we can see that du by dt we have calculated the d square u by dt square, that is a double derivative, that becomes c squared d square u by dx square at x is equal to u is equal to x and 0 fx du by dt fx0 is equal to gx. So assuming gx is equal to 0 for simplicity, so the element solution says that uxt is equal to 1 by t fx plus ct plus fx minus ct. So when we simplify this, we will get this particular equation that this is the constant value for x plus ct constant, f x plus ct is a constant in the slope which is minus c, and this is a slope which is showing c. So x minus ct constant, fx minus ct is also constant the particular slope c. So here we need to understand that what is the physical significance when we are calculating this. So dx by delta t is equal to c naught. So 3 delta x is equal to 3 c naught delta t. So delta x is equal to c naught delta t and 2 delta x is equal to 2 c naught delta t. So what we are studying here, that from the given equation when the time is varying at a different values. Initially we study when time t is equal to 0. Now then we study the time t is greater than 0. So how the particular wave is increasing from the particular mean position, how it is varying from the particular mean position, how it is propagating either on the positive axis or towards the negative axis. Here it is, we can see it more clear that this how the variation is calculated, that how this particular variation is there, how it is moving in this side of the propagation or how it is moving in particular right hand side of the propagation. So the equation generally enables us to calculate all type of propagation. Then we have this characteristics line we have discussed. After this characteristics line, that we have to calculate the non-homogeneous wave equation. In the non-homogeneous wave equation, d2u by dt square is equal to c square dtu by dx square. So this is the fxt that we can calculate with the initial condition that again we are taking the value to be 0 at the initial condition, and then we are again forming the same equation. As you can see, as we have done in the Helmholtz equation, we are forming the same equation. uxt is equal to 1 by 2 fx minus ct plus fx plus ct plus 1 by 2c x minus ct to x plus ct gs ds 1 plus 2c and then fxt ds dz. So this is the particular solution of the solution equation of any kind of wave equation that we form. So what we have learned in this is how to make a solution of the Helmholtz equation, and after that we have formed a wave equation, and the wave equation enables us to calculate the propagation. When the time is greater than 0 or the time is varying, more time is varying, we can see that how the wave generally propagates from the mean position, how it is going up, how it is going down, how it is moving in the left and the right hand side up from the mean particular point. So all this variation are generally named that how there is a change in the amplitude, how there is a change in the frequency when the time period of the particular wave is changing. We have done in the homogeneous equation also, when we have calculated the double derivative, and when we have calculated double derivative, what we have learned that the calculation of the equation, when we make the wave characteristics, it shows the proper propagation of the wave. So the equation of the wave and the propagation of the wave is what we have learned in this video. Hope you have enjoyed this video. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.